Now we're going to do an example of solving a system of equations, linear equations, using the Gaussian elimination method. So the first thing we're going to do is write this as an augmented matrix. So let's do that. So we're going to get 3, 7, negative 15, 3, 7, negative 15, and then negative 12. And then we're going to get 1, 2, negative 4, 1, 2, negative 4, and then negative 3. And then negative 4, negative 6, and then 15 and 16. Okay, so there we go. So step 1 complete. Now we're going to use elementary row operations to solve this. Now, the first thing we need to do is we need to get a leading one here in the first entry, right? Because we want to get leading ones going down the diagonal, right? Because each of the rows should have a leading one in it, and the leading one above it should be to the left, right? Remember, the leading one in each row is to the right of the row above it. So what happens is that gives us a diagonal of ones, right? So we'll have a diagonal of ones, okay, when we do this, right? So, and then once we have an upper triangular form, right? That's the row echelon form, as you'll see, right? So we want each of these diagonals to be a 1. Now here's the thing. Notice that this 1 here in the first column, this is already a 1. So the easiest step to do is just swap these two rows, and we've achieved what we wanted for the first row, right? So let's just do row 1 interchange with row 2, right? And so that's going to give us what? That's going to give us the following result. It's going to give us 1, 2, negative 4, negative 3, and then 3, 7, negative 15, negative 12, and the third row doesn't change. So that's going to be negative 4, negative 6, 15, and 16. All right, so now we've got that. Now, what do we want to do? So now the next thing is we want, what did it say, right? So what is the step, right? Okay. So now what we want to do is we want to eliminate these two to be 0, right? We want the 3 and the 4 to be 0. So this is where the 1 becomes very handy, and that's why we want the leading 1, because we're going to use the leading 1 to get rid of the 3 and the negative 4. So how are we going to get rid of the 3? Well, this is where we're going to take a multiple of one row and add it to another row. So we're going to take negative 3 times row 1, negative 3 times row 1, and add it to row 2, and then replace row 2, right? Because if we multiply negative by negative 3, row 1 by negative 3, we get the opposite value. This should look familiar. We get the opposite value of the same entry in row 2. And so if we take negative 3 times row 1, that's going to give us negative 3, plus 3 is 0. So row 2 is going to change. So row 1 stays the same. That doesn't change. We don't want it to change. Okay? Now row 2 is going to change. So this is going to become 0. Then we take negative 3 times 2 is negative 6, plus 7 is going to give us 1. And then if we take negative 3 times 7, that's going to give us 12. 12 plus negative 15 is negative 3. And then negative 3 times negative 3 is 9. 9 plus a negative 12 is negative 3. Right? So just make sure you double check your math. So negative 3 plus 3 is 0. Negative 3 times 2 is negative 6 plus 7 is 1. Negative 3 times negative 4 is 12. Plus a negative 15 is going to be negative 3. And then negative 3 times negative 3 is a positive 9. Plus a negative 12 is going to give us negative 3. All right? So far, so good. Now we're going to do the same thing with row 3. So we're going to take now we're going to take 4 times row 1. So now we're going to do 4 times row 1 plus row 3. And we're going to replace row 3. So now it's going to be 4 times 1 plus negative 4 is 0. Then we're going to do 4 times 2 is 8 plus a negative 6 is 2. And then we're going to do 4 times negative 4 is negative 16 plus 15 is going to give us a negative 1. And then 4 times negative 3 is 12. Oops, I'm sorry. 4 times negative 3 is negative 12. And plus 16 is going to give us 4. All right? So now that gives us the resulting value. Now look at this here. So now what happened was now we're done with this column, right? So now we're going to go to the second row and look for the leading one. Notice the leading one is already here. So now we're just going to have to use the leading one, right? The leading one to get rid of the 2. So all we have to do is do negative 2 times row 2 and add it to row 3. So we're going to take negative 2 times row 2 plus row 3, and we're going to replace row 3. Now, row 1 stays the same. So that's going to be 1, 2, negative 4, negative 3. Row 2 is also going to stay the same. So we get 0, 1, negative 3, negative 3. And now what happens? This is going to stay the same because 0 times anything is still 0 plus 0, 0, right? So that's going to stay. So that's the other thing too, why we do it in this order is because we want to make sure we don't change anything as we move left to right. So we don't want to, once we deal with this, then we're good. Okay, now. Okay, so now we're going to take negative 2 times row 2. So negative 2 times 1 is negative 2, plus 2 is 0, so this becomes 0. And then we take negative 2 times negative 3, which is 6, plus a negative 1, which is 5. And then, what? We take negative 2 times negative 3, which is 6, plus 4 is 10. All right? Now so we've got our leading ones. Now we just have to deal with the last row now. And so to change, all we have to do, remember the first step is change this to a 1. Okay, so all we have to do is divide that by 5. So we're going to do what? We're going to take 1/5 of row 3 and replace row 3. So everything else above stays the same. So we've got 1, 2, negative 4, negative 3. And then we got 0, 1, negative 3, negative 3. And then we got 0, 0, 1, 2. And now we're done. because now the matrix is in row echelon form. Okay, this is row echelon form. So here you go. So we've got this upper triangle, right? We've got the diagonal of ones and everything, and then then we've got this what we call the upper triangle, right? So upper triangular form. It's also is what we call row echelon form. So now what we can do is now we can back substitute, right? And how do we do that? Well, because we start at the bottom, and what is this? Remember what this means. This column represents X, Y, and Z, right? So X, Y, and Z. So this is what? This is saying 1 times Z is equal to 2. So Z is equal to 2. Now we're going to back substitute because this represents what? 1 times Y plus negative 3 times Z is equal to negative 3. 1 times Y plus negative 3 times Z is equal to negative 3. So this is where we get this equation. Okay? Now, but we know Z is equal to 2. This is where the back substitution comes in. So this is 2. So now this gives us Y minus 6 is equal to negative 3, which then tells us that Y is equal to what? 6 plus negative 3. Which equals 3. So Y is equal to 3. And now we know Z is equal to 2, Y is equal to 3, and now we go to the top row, which this represents what? X plus 2Y minus 4Z is equal to negative 3. But now we can plug in 2 for Z. We can plug in 3 for Y, and then we just solve for X. Okay? And so if we plug in 2 for Z, if we plug in 2 for Z, we get negative 8 here. And if we plug in 3 for Y, we get 6 here. So 6 plus a negative 8 is going to be negative 2. Right? So we get X minus 2 is equal to negative 3, and if we add 2 to both sides, we get X is equal to negative 1. And so just like before, the solution to the system of equations is then what? It's the set of all triples, and where what? X is equal to negative 1, Y is equal to, hold on, X is equal to negative 1, oh, Y is equal to 3, and Z is equal to 2. Right? So the solution is one triple, one point of 3 planes, right? So remember, the system, each one of those equations in 3 unknowns represents a plane, right? And so this is saying that the plane intersects at 1 point. Okay, and that's the solution set. Not bad. And that's how you do Gaussian elimination. Practice.